unto this day we still give praises unto honor unto the Lord for all his provisions. And today I'll simply take you through some few topics of mathematics. So mathematics is one of the easiest subjects, although some people take it as difficult, but today we shall really prove is it easy or it is hard as some other people say. It indeed needs some time, not as other people think it, but just need some daily practice. As you keep on practicing, the more perfect you become. So mathematics' principle is all about speed and accuracy. So how can you attain this speed and accuracy? It's by you practicing on a daily basis. So today I'll just take you briefly through mapping and functions. So I'll take you briefly through mapping and functions. Mapping and functions. So I'll first of all begin with mapping. So under mapping, we can talk of one-to-one mapping. We can talk of one-to-one mapping. So if I'm having, for example, I'm having A, B, and C, and maybe I'm having D, E, F. So this A can map maybe to E, maybe B mapping to this, and this to that. So this is what we call one-to-one mapping, where you find that each individual is mapping to a separate individual. So that is one-to-one mapping. Still, we can have one-to-many. For example, I can have my A, maybe here B, C, D, E, F, G. You find like this single A is mapping to this, still to that, and that. So this is one-to-many. Still B can map maybe to this, and that. So this is B mapping to that. So this is what we can call one-to-many. We can still have another kind of mapping which we can refer to as many to many. For example, I may have, maybe I have my A, B, C, and maybe I have here D, E, F. You find that this A is mapping to this, and maybe that. You find still this is mapping to this, maybe this, and also mapping to this, maybe C to that, to this, and again to that. So this is what we say many to many mapping. So that is all about mapping, but still we shall look at what we call a parallelogram. This is just a mathematical diagram used to represent some statement in mathematics. Parallelogram. Shall look at a parallelogram. So it's just simply as drawn as a circle. So they can give us a statement and say, using a parallelogram, draw or using a parallelogram, represent the statement is a factor of 2. So maybe they have told us represent the statement is a factor of 2. So simply you have to need to know what a factor is, and by definition we can just simply say that a factor is that number that divides a given number without a remainder. That's what we refer to as a factor. Then we have to find out which are those numbers that divide 2 without a remainder. Simply, we know that 1 is a factor of every number, since it divides all numbers without remainders. So if I'm to represent this information in a parallelogram, I'll have to draw it as this. So since 1 is a factor of every number, I'll include it there. I also have to maybe to include a 2 itself, because it can divide 2 without a remainder. So since 2 is a factor of itself, I'll just draw a ring around it, then I put an arrow to show that 2 is a factor of itself. So this is 1 which is a factor of 2. So I will have to draw an arrow and show that this one is a factor of, where the of ends, that's where we put the arrow. So 1 is a factor of 2. So see, they can give us, they can tell us to draw a parallelogram. Draw a parallelogram to represent the statement is a multiple. Or you can say draw a parallelogram. Draw a parallelogram. Draw a parallelogram to represent the statement is a prime factor. Is a prime factor of 3. Is a prime factor of, maybe you can say prime factor of 9. So we have to take now note of two things. They have added the word prime and factor. So we knowing by definition that a prime number is that number that has two factors, one and itself. So we shall look at those, and by definition a factor is that number that divides a given number without a remainder. So combining the two aspects, we shall look at those numbers that really divide 9 without a remainder, but they have to be prime. So I looking at only factors, I'll have factors like 1, 3, and 9 itself. Those numbers can divide 9 without a remainder. But bring in the aspect of prime. Is really 1 a prime number? No. 3 a prime number? Yes. And then 9 a prime number? No. Reason being, they don't have two factors. So we shall take 3 because it has two factors. So it applies for both prime and being a factor of 9. So I'll just draw my parallelogram. And this is the 3 and this is my 9. So I'll just represent and say 3 is a prime factor of 9. So leaving that aside, we shall see more examples concerning that. So let us just go ahead and look at functions. Let us look at functions. So looking at functions, given the domain and range, so I can take the domain as my object and the range as the image. So we can really find out mathematically, given the domain we can find out the objects in the range, as well given the range you can find out the objects in the domain, or we can find some objects missing in the domain and those missing in the range. For example, given this question, for example, I have this in the domain, maybe I have 2, 5 and maybe 7 in my domain, and this is having a relation as x is relating to give us maybe x plus a 2. So we have to look for the objects which are in the range. So this is something easy. So given the objects in the domain, we said we are taking them as our objects. We need to find the objects which are in the range. Simply we shall have to say, using a relation, that f of x, given this x, we are taking this as our f of x, will give us x plus a 2. So we are looking for the objects in the range. Very simple. So for this case, since we are having a 2 here, we shall look at what it is mapping to in the range, the corresponding value of 2, using this very expression given to us, that f of x is equivalent to x plus 2. So let us find out and see. So since we are looking for the objects in the range, we shall just have to substitute in each of the items in the domain. So we shall have to look for now f of 2. F of 2, where there is x, we just substitute in a 2. So this will give us a 2 plus a 2, which will give us a 4. That is done. This is my 4. Then still we have to look for f of 5. This will give, where there is x, we put 5 plus this 2 which is already there in the expression. This will give us this is the 7, we put it there. Then still we can look of f of now say 7. which will give us, where there is x we put 7, 7 plus 9 verse 2 shall have a 9. So still using the same example, they can give us that same thing, but they require us to find the objects, like the objects, what is in the domain. So given the range, how can we find those objects, or how can we find the elements that are in the domain? So also very simple. So given the range, for example, they have given us that the objects in the range, I'll just use the above example So objects in the range, they are given maybe as 4, 7 and 9. They tell us to find the domain. They tell us to find what is in the domain. So also very simple. So we want to find the objects in the domain. Is it okay? So they have given us, we are going to use this same example. So using a relation, if you are using a relation, x giving us x plus 2, we are using the same above relation. So how can we deal with that? So since if this is our domain and we are looking for, this is the range, so the range they gave us 4, 7 and 9. So we are looking at what is in the domain. Simple. So still we shall use that expression we are having there, that f of x is giving us x plus 2. So since our f of x is giving us x plus 2, but now we are looking for objects that are in the domain, given those in the range. So for this case, we shall not just feed in. So where we see f of x, since we have the object, like we have the image, or we have objects, like we have elements in the range given. So where we see this f of x, we shall just substitute in that element in the range. For example, here we can see that the first element was 4. So where we see the f of x now, we can just put there a 4, and we say the 4 will give us now x plus 2. So collecting like terms, we shall have 4 minus 2. This will give us the x. So our x will give us a 2. So mean that the first answer we're having here is a 2, which idea we can see above was a 2. Then we can use still the same expression, that f of x is x plus 2 on the others. So this is 7. We shall substitute in where we see f of x, where we see the whole of the f of x, we shall put there now a 7, as we see the next element there. So you can put 7 equals to x plus 2. So the 2 crosses the equal sign, we have 7 minus 2. This will give us our x. So finally 7 minus 2 will give us a 5, which is equaling to our x. So mean that our x is corresponding to a 2. So we can put here so we had 7, our x is corresponding to a 5. So we can come here, we put there a 5. So as well we can see it was a 5 up. So still, where we see f of x, we can just substitute in with this other remaining one, which is a 9. So our 9, where we see f of x, will give us x plus a 2. So we collect like terms, we have 9 minus 2 giving us the x. So x will equal to 7. So we can as well come and put our 7 here. So we can ideally see that this same thing, no matter what they bring, we can still do it the same. We can see with the first example that we did, they are corresponding. So We shall find out other examples at the end of this topic. We shall do more with examples because we know practice makes perfect. So at this stage, let us look at some of the simple functions. We shall look at some of the simple functions. We shall look at some of the simple functions. Simple. We shall look at some of the simple functions. For example, they can give us maybe example 1. They can say f of x is given as x plus 5. Find f of 2. Then B Roman numeral number 1, f inverse of x. Yes. B Roman numeral maybe number 2, find f inverse of 3. So it's all about you. Mathematics, you just get a concept, then you can apply it widely. So we need just the concept. So ideally here it is very simple. Given that our f of x is x plus 5, find f of 2. So we can just substitute here f of x. Solution, our f of x is equivalent to x plus 5. So they want f of 2. So where we see x, since this is matching with this, we shall just have to substitute. Where we see x, we put there a 2. So it will be 2 plus 5, giving us a 7. So that is part A is done. Then B Roman numeral number 1, they want us to find f inverse of x. How shall we really find the f inverse of x? Simple. Still, if you want to find f inverse of anything, we shall just let any unknown. For example, I say let m equal to that very expansion given. We are using f of x equaling to 5, x plus 5. So I will let m equal to this function, which is x plus 5. So our intention of letting, we want to make that x the subject of the subject of the formula. So making x the subject of the formula, we shall have 5 coming this side, becomes a negative 5 minus m minus 5 equaling to x. So we shall have our x left independent. That's what the simple term of making the subject of the formula. So we make that term which they have told us, or we make it stand independent on the separate side of the equal sign. So since we did not have this m in our expression, in the final answer where we have to look for the f inverse of x, we shall replace the m with the x. So we say f inverse of x that we are looking for will be, where we have m, we put there x minus 5. We have simply found the f inverse of x. But Roman numeral number 2 is telling us to find now f inverse of 3. So f inverse of 3, put in mind that you will never get f inverse of 3 if you don't have f inverse of x. But simply we had initially found the f inverse of x, so we just have to use f inverse of x, which we had initially gotten, which was x minus 5. So this will give us, so they need f inverse of 3. So this since these are the same, f inverse, we shall just say, where we have x, we put there 3 minus 5, which will give us a negative 2, which is also okay. So that is it. So we can also look at another example where we have maybe given that h of x is x squared over 2x. They tell us, Roman numeral number 1, find h inverse of 4. Roman numeral number 2, find h of x for which the function is meaningless. Another term they can use, they can say undefined. As well, knowing numbers, they can tell us meaningful. Or defined. So we are looking at some of the simple functions. So for this case, what we shall do is very simple. We know that we can never find the f inverse of 4 unless we ought to first look for the h inverse of x. So it's better we first look for the h inverse of x. So it's one question, but it has two stages where we have to first look for the h inverse of x. Then after looking for the h inverse of x, we shall in turn look at the h inverse of now 4. So what shall we do? So simply following the same procedures, solution Roman numeral number 1. So how shall we find the h inverse of x? So this is the term given to us. I can let that term, which is x squared over 2, let that equal to any unknown, for example equal to a n. So from there I have to make x the subject of the form, making x the subject of the formula. So I'll simply first of all have to first cross multiply. Since it's having an equal sign, I will cross multiply this and this, then this and that. So I'll have x squared giving me n to x. I've cross multiplied. From there, it is ideal that this is in form of a quadratic equation. So it's better for us to find x. One is in power 2, then we're having one in power 1. So we shall bring them on the same side. So we have x squared minus 2na x equaling to 0. So from there, we can continue by completing squares. So I know you have a concept about completing squares. So when you're completing squares, you have to make sure that is our quadratic we are having. We cannot factorize since one is in power 2. So we ought to complete squares. So since we don't have a constant, we can just go on. But since if we had a constant, then it would cross the equal sign. But for this case, we don't have a constant. Then the second step would have been, we look at the coefficient on this x squared, the coefficient on x squared. If it was anything above 1 or any other coefficient which is not a 1, we had to divide it throughout. We'll make sure that the coefficient is a 1. So that is step 2. Then step 3, we look at this sum here. What do we do to the sum? We look at the sum, make sure you multiply this sum times a half. Then the answer you get, after multiplying that sum by a half, the answer you get, you square it, add it both sides. So when we multiply this sum by a half, we like having this 2nx times a half. The 2 goes with that, we remain with n. So remember, we are taking the coefficient. So this x is not inclusive. We just take the coefficient, which is 2n. You can rather take it with a sign or just take the number like 2n. So I've taken 2n times a half, I get an n. So the answer we said we get, we square it and add it both sides. So that's what I'm having. So look at this, multiply it by a half, you have a n. The answer you get, you square it, it becomes n squared. So it is the n squared we shall add on both sides. So x squared minus 2nx, we add n squared here, equals to 0 plus n squared. So we shall have x squared minus 2nx plus n squared. Remember, we added n squared on both sides, equaling to n squared. Reason being that when we add n squared to 0, we end up with n squared. But now we can simply see here, Since this is squared and this is squared, we shall just take x here, and here we take a. Then here we take the first sign, which is a negative, but we square all over there. So simply when you expand this, you'll have to go back there. You can try it and see. When I expand this, do I really come to this? This will equal to n squared. So at this case, we are making x the subject of the formula. But now what we have to do, since the x here is covered by this squared, we have to make sure the only way of removing this square is by putting a square root both sides. So I'll put a square root here. I say n. Do you remember the square was squaring both this? So I also put a square root on this side. So since this is not having any operation sign, also to give us a final answer as n, then the square goes with this, so we have x minus n. So we make x the subject, the n crosses the equal sign, becomes n plus n. So our x will equal to 2n. So we have found the h inverse of x. So we finally say that our h inverse of x will be 2. Where we see the n, we put there x. So what about the h inverse of 4, which they wanted? It will ideally be 2 times a 4. Where we see x, we put there a 4. This becomes 8. So the h inverse of 4 is 8. So let us see part Roman numeral number 2, where we wanted the function, the value of h of x, for which the function is undefined. We say, take note, when they say undefined, we equate the denominator. What is in the denominator to z? So what do we have in the denominator here? We have 2x, so we shall just equate 2x to z. 0 is set to x equals to 0. So dividing both sides by 2, x will equal to a 0. Then one number 3, where we have meaningful, we just equate the numerator to 0. So we have x squared will equal to a 0. Taking root both sides, our x also be a 0. So we shall continue from there.